If you were looking up at the night sky and I asked you to tell me what one of those points of light were, you would say that it's a star. But probably you would be wrong, because most of the stars astronomers have cataloged in our galaxy have at least one partner. That little point of light probably isn't a star, it's probably stars. In binary systems, two stars orbit around each other. Sometimes they're roughly the same type of star, and sometimes they're so different that one is eating its companion. We've tracked pairs like this in our galaxy, but never taken detailed measurements of a binary outside the Milky Way. At least that was the case until 2 weeks ago, when astronomers announced at a meeting of the American Astronomical Society that they had observed not one extragalactic binary, but two of them. They found them in data from the Sloan Digital Sky Survey, which has monitored stars in the Milky Way and in neighboring satellite galaxies since 1998. One binary is dubbed Draco C1, and it's inside the Draco Dwarf galaxy. The other is named Lin 358, and it's inside the Small Magellanic Cloud. Both of these binaries involve a red giant and a white dwarf, so a huge star plus the colder, dead core of an old one. And maybe unsurprisingly, picking out these systems was no small feat. Relative to interstellar, or in this case, intergalactic space, stars are tiny. So when you're looking for distant binaries, it's extremely hard to distinguish one star from another, especially when one of those stars is a little white dwarf. But there was something that helped. In both binary systems, the white dwarfs are slowly eating their companions. Their gravitational pull is so strong that they are stealing gas from the red giants, and that extra material makes the white dwarf extra bright, so it's easier to notice. Now, the big thing with this study wasn't just that we found binaries outside the Milky Way, it's that researchers were able to study them in detail and learn about the stars' masses, plus the sizes and shapes of their orbits. Doing that required tracking the star's light over multiple orbits, which took years of data. Like in Lin 358, it takes more than 2 Earth years for the stars to orbit one another. In Draco C1, it's every 3-ish years. And that's why the long-running Sloan Digital Sky Survey was so helpful. As research like this continues, astronomers are hoping to learn if binaries are just as abundant in dwarf galaxies as they are in the Milky Way, but they're also looking to validate a key idea about supernovas. In some binaries, white dwarfs explode when they steal too much gas. Those explosions are called Type 1a supernovas, and their brightness is really consistent from one explosion to another. So what their light looks like is a direct clue to how far away they are, and we use them all the time as cosmic distance markers. So by tracking binaries outside the Milky Way, astronomers are hoping to confirm that these explosions are definitely the same no matter what kind of galaxy they're coming from. Meanwhile, while some researchers have been breaking new ground studying stars, others are reevaluating how you break ground on other planets. Because earlier this month, NASA decided to call it quits on trying to fix part of the InSight lander mission on Mars. InSight landed in the Elysium Planitia region in November of 2018. It was designed to teach us about Mars's interior, including where its heat comes from and how it's affected the planet over billions of years. And to start figuring that out, InSight was supposed to dig a hole at least 3 meters deep using an instrument nicknamed the Mole. It's a thin, 40-centimeter long pile driver connected to the lander, and the tether has temperature sensors along it. So after the Mole hammered itself a few meters into the soil, the sensors could start taking data. But the team and the Mole ran into a problem. The dirt they were trying to dig through wasn't the consistency they'd expected based on the soils analyzed on past missions. They thought the soil would be loose, and that as the Mole dug down, the walls of its hole would collapse around the top part of the instrument. Then, as the Mole pushed against that fallen soil, it could generate enough friction to keep propelling itself farther down, rather than bounce back up from the hammer's recoil. Except, at Elysium Planitia, the soil sticks to itself too well and doesn't collapse. So when the Mole tried to dig, that friction wasn't there, and the instrument ended up popping out of its hole. To fix this, the InSight team first tried pressing the lander's arm against the Mole to add some resistance, and that did get the instrument to tunnel down about 38 centimeters, but it still kept popping out of its hole. So to continue the most delicate game of whack-a-mole ever played, and most expensive, the team then tried piling some soil over the instrument and then pressing down on it with the InSight's arm arm. But that still did not do the trick. So after one more failed attempt earlier this month, the team had to call it quits. The mole just wasn't made for the environment it ended up in. But that's actually the silver lining here. We might not learn as much about Mars's temperature this time, but we know more about how diverse the soil can be, and that will help us prepare for the next mission. Also, InSight as a whole definitely hasn't been a waste. Its seismometer is still running, and it continues to provide us with information about Mars's insides, like how frequent Marsquakes are. So overall, research like this can sometimes feel like one step forward and two steps back, but really, we're learning new things every step of the way, even if success doesn't look like what we'd hoped. Thanks for watching this episode of SciShow Space News. If you want to keep learning about InSight, you can watch our episode from early 2020 about the mission's first results.